Good afternoon. First of all, I'd like to, this is known as the graveyard shift, just immediately after lunchtime, so it's very difficult to keep people awake. But on the way down the stairs, I handed out sweeties to people, and it's just a little form to get people to start putting up their hands, because I want you to answer me in some of the questions here. So, who got a sweetie from me or a sweetie on the way down the stairs after lunch? Excellent. Keep your hands up, because you're also the people who did not hold the handrail. Now, it's not like me to name and shame. Well, it is like me to name and shame. This is a safety conference, and we've been talking about safety, and Anne, the moderator, gave us clear instructions to hold the handrail. And at lunchtime, before lunchtime, I noticed about 50% of the conference was actually holding the handrail. And in my company, ConocoPhillips, if we see an incident, we own it. We have to do something about it. So I've done something about it. I may be handing out sweeties at the coffee break. Okay, moving on. So first of all, OGP. How many people have heard of OGP? Excellent, the hands are going up. Okay, so there are more than 70 members around the world. Integrated oil and gas companies, ConocoPhillips, Shell, BP, all the big ones, 70 are in there. Small independent companies, all the small little ones who are working around. National oil companies, service companies, Baker Hughes, Halliburton, Schlumberger are very, very active in all of these conferences. 15 national associations, API, IEDC, OLF, and NOHEPA from here. So the chances are that your company is part of OGP. Remember that. We're based in London, and we have an office in Brussels, which we use for companies which work in the EU area. They pay an extra amount of money to support that Brussels organization. So, after Malcolm and the UK set up OSPRAG, I was actually a member of OSPRAG, and my company was also a member of OGP. So OSPRAG started off with a really good set of implementations, which we just heard from Malcolm, and a lot of other regulators around the world were saying, well, hold on, what about a capping device for us? We need a capping device. So the GIRG was generated, the Global Industry Response Group. And our task was to look at the whole industry, the global industry, to look at the accident prevention, intervention, and response. So we produced a GIRG report. How many people have heard of the GIRG report? How many people? Keep your hand up if you have read the GIRG report. A lot less. That's disappointing. That's really disappointing, because 100 of the world's experts in well control took almost 6 months to write that report. And that report contains some recommendations which certain regulators have said should be made into an ISO standard. It says things like having 2 barriers tested in direction of flow at all times on the wells. It says things like you should have a competent regulator. It doesn't just talk about the industry, it talks about the regulator. It says he should be competent as well. It talks about human factors, it talks about blowout preventers. If there's one thing you do today, is leave this room and go and read that report. I honestly, if you follow what's in there, your chances of having a major incident will vastly be reduced. Oh, let me go back. So, there was 3 groups. Prevention, that's mine. I think that's the most important, obviously. Intervention and response. Intervention is once you've lost control of a well, you put a capping device on and try to stop the flow. And the response is when you've got oil in the water and you go over and try to clean it up. So from the Global Industry Response Group, the GIRG, we set up 3 committees: OGP Wells Expert Committee, which I'm the chairman of, The intervention JIP with these companies, which is based in Stavanger and is designing and manufacturing capping devices. I'll show you these later. And then finally, the oil spill response group. When Director Bromwich of BOMA came over and talked to us, he said, prevention, you have written a report on that. Intervention, we're now starting to see capping devices. But oil spill response, he said, the equipment that I saw picking up oil off the water at Macondo looked as though it had been manufactured in someone's garage. And it really does. It's very Heath Robinson. The industry has put a lot of effort into prevention and intervention, but not much money and effort into what do we do when there's oil in the water. So that's a big JIP, and there's a lot of deliverables from that. So on to my own one. We've got 30 experts, and we've got 4 task forces at the moment, and we're working on BOP and well control incidents database. That's the first one. Then blowout preventive liability and human factors and international standards. Now, we've been talking about well control, and you can have, we talked about Macondo, for example, 8 barriers failed. One way to look at those barriers are as lines of defense. Like your innermost line of defense is the blowout preventer. That failed in Macondo. Your procedures, that failed in Macondo. Your competence of your people, the presidential report says that failed in Macondo. Cementing and hydraulics, yeah. Mud and hydrostatics, well, we pumped that out the well. And finally, the well design. So all of those barriers failed. And finally, the BOP failed, and we ended up with a well control. So if you look at it as a defense and depth, all you need is any one of those barriers to hold, and you do not have a well control incident. So the first thing that we've asked for is a well control incident database. And this is where, when you have a well control incident, you put it to a database and it goes around the members of the industry. Why do we need that? How many people are aware of the incident that happened 6 months before Macondo in the North Sea? On board a ship. There we are. Very few people realize that there was an event in the middle of the North Sea on a Transocean rig. This is not my words, this is in the presidential report, which was identical to Macondo with one difference. The difference was that the shear rams were closed in time and the event did not happen. That was 6 months before on a Transocean rig, and that lesson was not taken to the rest of the Transocean rigs. We've got the SINTEF database in Norway, and it tells you about well control incidents. And there's quite a lot of them, but if you categorize it and go into that database and categorize it, it will tell you what the barriers that failed. And if you go through the incidents on offshore platforms, you'll see cement failed, cement failed, cement failed. That's about 80% of well control incidents occurred because cement failed. The second barrier failed, which is normally the BOP. The most common reason for the BOP not working is the BOP was not in place. So you can have a really good BOP, but if it's not sitting in the well, you've got a problem. That's not a barrier. If you make sure when you cement a well, and let's go through the sequence. You've run casing, you put the cement into the well, and then you wait for 24 hours for the cement to set so you can then do a pressure test. 24 hours. Let's do something. Let's just slacken off a couple of the bolts to the wellhead. That'll be okay. We'll slacken off another couple, and that'll be okay. The cement's set, and don't worry about it. And then suddenly the well comes in. Why does the well suddenly come in? Because the cement has turned from a liquid, which has got a hydrostatic, into a solid, and if the cement job is not good, you've just got all the water out of that, and you've now got a well coming at you, and you've just unbolted the BOP stack. If we stop doing that, we will eliminate 80% of the blowouts in this world. That's straight off the SINTEF database. So we've generated this. It is with the committee, and it's going to go live, hopefully, in the start of next month. BOP reliability. How many people have heard of Standard 53, API Standard 53? There we are. Some people are aware of this one. Well, after Macondo, there was a recommended practice 53, and it was upgraded, and the American government said it should be made a standard. And it looks at how many shear rams that you trim the well to, and that standard now has a description of the BOP stack you should use for subsea wells, and it is in fact the Macondo BOP stack with double shear rams. And we're now looking at that to see if it's actually what we need to do, because that is very much a prescriptive system as opposed to a risk-based system. If you look at the BOP itself and expand that up, the BOP has shear rams, it has pipe rams, it has an annular, it has a control system, well-controlled procedures, and it has pressure and temperature ratings. Once again, it is a series of defenses in depth. If those start failing, then you can have a failure of your BOP stack. But the whole industry has been looking at shear rams, the very final line of defense for your blowout preventer and for your well. But what about the well design, the mud and the hydrostatics? We should also be concentrating on that. And that's what we're trying to look at with BOP reliability. How many people have heard of SIL, Safety Integrity Levels? There you are. It's used in nuclear reactors. It's used in control systems inside chemical plants. It's used throughout the world. It's used in subsea Christmas trees, but it's never been applied to blowout preventers. So we're going to do that study and work out what it is. It's been done with IADC. Now we come to human factors, training and competence. We've all talked about competence today. Notice not too many people talk about training anymore. Training is only one of the elements. If I could give you a definition of competence, a competent person is a person who has the knowledge, and he's developed some skills to apply that knowledge, and he has the right behavior. If that person has all three of those, that person is competent. And I'm an engineer, I like equations, so I say competence equals knowledge times skills times behavior. And the reason I say times is that if any one of those goes to zero, your competence goes to zero. Let me give you an example. My company had an electrician, senior electrician. He was one of the most senior people in the company. He used to train the youngsters on how to do things safely. It was his job. He was very, very respected. He had the knowledge. He was a training instructor. He had the skills. He checked people in the job. He had many, many years of experience. But one day, he decided not to isolate a line. That day, his behavior was zero. And the competence went to zero, and he killed himself. So it needs all three components, or you do not have a competent person. How many people have got a well control certificate here? Excellent. Keep your hand up if you think you're competent in well control. I've got a certificate, but would you let me go and work on a rig right now with my certificate? I've not worked on that equipment. I don't know what I've done. I've never seen this equipment before. Just because I've got a certificate does not mean I am competent. And that's what we're trying to get with competence. The other thing about human factors, we've all heard from Macondo that there was the rig had blown up and there was flames belching through the rotary table and there was people diving over the side. And there was a person with the finger on the button to disconnect the rig. And they did not disconnect the rig. They waited for 5 minutes until someone in authority came in and gave them the authority to press that button. But when they pressed that button, the control system had been burned and it was too late. Why did that person wait? Why did that person not press the button? Why did they feel they did not have the authority? Did it maybe have something to do with a previous incident where a driller had thought he had seen a kick and he shut the well in? That's what he's supposed to do. Drillers are supposed to shut the well in if they see a kick and then ask questions later. And it turned out it wasn't a kick. He was reading some gauges wrong. There was something going on with the pumps. There wasn't flow. And everyone opened and said, no, it's not a kick, that's fine. And the company man came along and said, okay, well, we've just wasted 15 minutes of rig time now. So what we're going to do is we're going to put this rig onto 0 rate for 15 minutes, and that's on your time. What kind of message does that actually give? What kind of message does that give to that driller? Will he press that button the next time, or will he wait? And that's what we're talking about, human factors. We're starting to get into this really serious stuff that we're going to be hearing about in the final session. So we've got a program on that. We're going to be teaching how to have crews trained in human factors, and we're also going to have an assessment tool so that we can assess that the crews and the team are actually operating properly. Let's talk about this driller. I'm quite worried about the driller, by the way. We keep on giving him more things to do. You know, the driller's up there, he's got well control to look after, he's got the derrick to look after, there's people scrambling about the drill floor, and we give him a monitor to watch the ROV, and we give him another monitor for the pumps, and we give him another thing to operate the pumps. He's got so many things to do. Let's take, for example, how many people flew here today on a airline or to get to the... Okay, so some people flew in, and at the front of the plane was a pilot. Now, let's say you have a pilot who makes a pilot error. Let's say you've got a pilot with 400 souls on board, and that pilot makes an error and slams a jumbo jet into the center of the Atlantic after taking off from Rio. Does that bring a company the size of Air France to its knees? But that pilot has been trained for years. He's been trained for many years. He has to continue his competency. He has to do simulations. He has to do tests to make sure that that guy is competent. Yet, if he makes a mistake, he does not bring a company the size of Air France to its knees. Now, let's take a driller. What sort of qualifications does a driller have? Qualification is probably he was AD. Qualification before that was he was a roustabout. So we're now putting this guy in charge. He has very little education. We give him 1 week of training per year, 2 years. 1 week of training per 2 years. We don't test him. We don't give him simulations. We don't give him any checks. And if he makes a mistake, he can bring a corporation the size of BP to its knees. And the pilot has one other thing that a driller does not have. Can anyone name what it is? Co-pilot. The pilot doesn't fly the plane. The co-pilot flies the plane. The pilot watches the co-pilot. He's instantly watching that he's not making a mistake. So, you know, if you have the risk versus the danger, our industry is completely out of control in that respect. So we're going to try to improve it with this. Let me move on before I run out of time. Other thing is international standards. We intend to take the work which we've done and make them into international standards. I presume we have some Americans here. Americans, API. API would like to be the global industry standard. It may come as a bit of a shock to some Americans, but not every country in the world likes the A of API. You can have a perfectly good standard, a brilliant standard which tells you exactly what to do, but some countries will simply not use it because it's an American Petroleum Institute standard. And there are some big countries there. So we have to go to ISO, International Standards Organization. So a lot of the work which we're going to do is go to an ISO, and a lot of the work which we're doing is based upon the work that was done in OSPRAG, because that's excellent work. We've taken some of that. Now, this is work which is, these are actually documents which Malcolm showed us, which is produced by the Well Life Cycle Practices Forum. The Centre of Offshore Safety is working on an audit for environmental management systems. APIA, they've produced a safety management checklist. If you look at all of these, we're not doubling up. All these organizations around the world are actually working on different things that will mesh together to give all the recommendations from the GIRG report and the OSPRAG report. So we are actually working all together, each doing little bits which will bring the whole picture. Okay, on to the Subsea Well Response Project. This is the capping devices. So OSPRAG have their capping device. So we take the capping device, we have a blowout in the UK, we take the capping device, stick it onto that, and then we say, right, everybody else in the UK stop drilling because we no longer have a capping device. Not a very good idea. We need backup. We also need, some countries don't have capping devices. So what we will do is, there's 9 global companies working together, a non-for-profit organization, and we are designing, and we're now going out for 15,000 PSI. These are bigger than the OSPRAG devices. One of them is full bore, 18¾ inch, and there's another one based on the OSPRAG 7-inch gate valves. We're also going to have immediate response toolkits. One of the big things about Macondo when it went off was the amount of volatile gases in the atmosphere. When they first approached it, they couldn't get anywhere near it. So what they did was went down with an ROV and started injecting dispersant right into the bottom near the plume. And that reduced the volatile gases on the surface, and they could actually get vessels in. That was one of the first things you need to do. So that's your emergency response. The first response you need to do is get some dispersant down in there to allow you to get vessels in there to clear the debris. And while you're doing that, you organize some 747s or some big heavy lift transport planes and move this to your location and then move it and put it on top. So there's a whole bunch of stuff. There's going to be 4 of these. One is going to Brazil, we believe. One is going to stay within the European arena. One's going to Asia Pacific. And the 4th one we're still negotiating. There's possibly an Africa area. And there's the dispersant toolbox I just talked about. So these are units which can simply be loaded onto a plane and taken to any location in the world. So 4 capping stacks, rapid deployment, improve the operational readiness, full global response. And finally, the Oil Spill Response Project. We have 14 companies now, JIP, and we're now going to develop proper equipment. On Macondo, one of the major things that had never been done before was actually in situ burning oil on the water. And it went from 0 to hero. The amount of oil which was removed on Macondo by simply burning it while it was still at sea was excellent. So we need to properly develop that technology and the booms for that. The emergency, yeah, here we go. Back one. Okay, so it's research and development and getting good practice for all of that. You know, one of the things that we did was, on Macondo, was we got a whole bunch of these suits that people wear. We stuck them in these suits. We stuck them out onto a beach and said, okay, go and start picking up oil off the beach. And all these people keeled over. They were working in atmospheric suits in tropical heat. There's no way we could do it. So these sort of things need to be sorted out. So, my conclusions. Action and prevention, this is my bit, will yield the greatest outcomes. please read the GIG reports. And please stop taking the blowout preventers off of wells when you've just cemented them. That will really help a lot. We don't fully understand how a cement works, by the way. We do know that it shrinks. And we do know that if you put too much water into it, you end up with a column of water up the side of the well bore. But if you don't know how it works, and you're prepared to take your well control process off the top before it's actually set and you've confirmed you've got a seal to the reservoir, you're just taking a chance. And you can have a company like ConocoPhillips, and we'll spend a whole bunch of money and say, right, we're going to have 2 barriers tested in direction of flow. If I want to remove that stack, I'll put 2 barriers in, and we'll do the right thing. But that costs us money. And then you get a smaller company who says, well, we're not putting 2 barriers in there before we pull the stack. We'll just put 1 barrier in there. We'll take the chance. And they'll pull the stack. But who are they taking the chance on behalf of? You know, if we get another big blowout in the middle of the Mediterranean, they take the chance on behalf of the whole industry. The regulators will get into trouble, the industry gets into trouble, and we're endangering people's lives. So we've, as proper operators, some of the big operators need to stop the smaller operators taking the chance. So we need to make sure that everybody follows the same rules. My company boss will say to me, well, hold on a minute, this small company is drilling wells faster than you are. And I'll say, yeah, but they're taking chances. They've only got 2 barriers in there. They can drill it faster. You'll say, oh, well, that's not good enough. I want to be competitive. So what my boss is basically saying is, be competitive, but follow all the rules. It's impossible. So we need to have a level playing field. So if everyone can follow the recommendations of the GIG report before it's made into an ISO, then that would be superb. Ongoing commitment from the industry. Certain parts of the industry have forgotten Macondo already. Certain parts of the industry are only concerned about the price of gas. And we want the gas price down, and if you have to do all this excess stuff for safety and reliability, then we'll do that later. So we need to make sure that the industry keeps up. And we've got to collaborate. We're keeping on collaborating, so we need to do that. And I think that's my last slide. That's the address where you'll get the GIG report. And the rest of my reports when I publish them. Okay.